Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, continuing up from last week's video about dealing cards and expected values. Now I'll link the video down below, but as a reminder, we talked about this AIME question where Alice has 3 red cards, 3 black cards. They're revealing one by one. Here, this time, she's making a guess before each reveal. And we wanted to figure out the expected number of guesses that she would have along the way there. How many of them were correct? And we did some nice stuff with expected values, and the key thing was this recurrence relation. So we had this recursive way of calculating the expected value. Right? She guesses red unless there's more black cards. Remember, she's seeing every card. So first card, red or black, and then you can use that for the other guesses there. So if there are R red and R black, well, we have a probability that it's red. And then if we're guessing red, we can say, well, then it's 1, and then our guess is smaller. Remember, we were doing the symmetry scenario where we're assuming that we have more red than black cards, because otherwise we have this symmetry argument going on there as well. So that's the situation we had. So if we have at least as many red cards, this is the probability we're correct. We have 1 correct guess. Now that red card is gone, and we continue. And we do the same thing for that other scenario with the black cards there. Of course, we have these starting values and things like that as well. Now, the question that was introduced from last time that we're going to be talking about today is, instead of guessing, Alice is betting. So the difference here is, right, if you get a guess correct, great. If you get it incorrect, that's too bad. You still go on from there. Here, however, right, we're talking about betting. So the difference is, well, she's betting all of her money for now, right? If she's betting X dollars, she would win X dollars. Meaning at the start, right, Alice has $1 at the start of this setup there. Well, if she's correct, she ends up with $2, right? She gets that extra dollar, she wins the 2x, but she paid in the x, so she has an extra $1. The issue here that makes things a little bit more interesting or a little bit more difficult, depending on how you want to think about it, if she gets that bet wrong, she now has nothing. So we can still use this same strategy as before. If it's a tie, bet red. If there's more red, bet red. If there's more black, bet black. And we want to find what is the expected amount of money she ends up with in this case. Just to make it clear, in a lot of the scenarios, she ends up with $0, right? If she's betting it all, then she could lose it all, and then she's stuck the rest of the way. Even if we know exactly that all the rest of the cards are black, if you have $0, nothing works out from there. So instead of this additive relationship, we have more multiplying. Every time she's either doubling her money or multiplying her amount of money by 0. So the starting with $1 is actually a little bit not that important. If we think about it in terms of doubling or multiplying by 0, it will work out that way too. Now, shouldn't surprise you, as practice from this, let's let M of RB be the expected amount of money Alice ends up with if she starts with $1 with R red and B black cards there as well. Again, you can think of this as multiplying. And so actually the recurrence will work because, oh, what if she started with $2 instead of $1? it's pretty clear then her final value would just be double what it was original. Now, what are the basic facts we have here? Well, we actually have the very similar types of things. So first of all, we do still have our symmetry. So we do still know that, and again, let me just use X and Y because I will be swapping these here. So the amount of money you would end up with X red and Y black is the same as if you had Y red and X black. And let's think about these zeros cases. Again, by the symmetry I just wrote down, I wouldn't need both of these, but just for making it a little bit easier and writing it out, what about if you have R red cards and 0 black cards? Well, this means every single time you can guess red, and every single time you will double your money. So this is 2 raised to the rth power. And again, by symmetry, we know this answer, but I just want to write it out so we have it. 0b is 2 to the b in that scenario there as well. So those are our basic facts, our base cases of the recurrence, if you like. So shouldn't surprise you that our next step here is going to be looking at the recurrence relation here again. Now, as before, remember we can assume that R is at least as big as B. Because if we have more black cards, okay, swap them, and by symmetry, the same equation would be true, just in the other direction. So we can assume that the R is at least as big as B in this case. Now, our general format is going to be the same then, right? We have M of R and B. And remember, because we have at least as many red cards as black cards, the strategy again is going to rely on us or Alice guessing red. We do guess red with this probability. So this is our guess is red in this scenario. Now here's where things are a little bit different than last time. We have to now be thinking of doubling our money. If our guess is correct, we are doubling our money. So we multiply this by 2. And then instead of adding what we get from the rest of the guesses, remember we're going to be multiplying. So we multiply this by M of R minus 1, comma, B. So we're now multiplying in this scenario there. And that is an interesting thing because, right, our guess could be wrong. And I'm going to write it out just so we see the pattern. We won't see this on upcoming slides because now you lose all of your money. So in fact, because of this times 0, of course, we don't need to keep track of this for later parts. So this part we can kind of cross out. I will cross it out here, but just kind of leave it as that can help us understand that recurrence. It looks similar to the previous one we had from last week's video in this way, but things are a little nicer because now it's not actually going to affect our different calculations we have there as well. So we focus on this first portion. We have, okay, if we have at least as many red as black, otherwise we use symmetry, we have what chance we have at doubling our money, doubling it, and then we have one less red card there. So let's use this like we did before and calculate the expected value for 3 red and 3 black cards, the expected amount of money Alice would win using this strategy. Now, we're going to notice some patterns and look at that in a second, but keep an eye out for those here as well. And we'll start kind of slow and then speed up along the way as well. Remember, we know that if there's only one card, you can double your money. So if we have one of each, right, you're guessing red, there's a 1/2 chance you are correct. And then, whoops, you are doubling your money. And then we multiply this by how much money you could get if there's only one black card there, right? So remember, assuming that if we have a tie, you're guessing red in this case. Well, let me write the first one out because we don't have that actually here. If there's only one card left, of course you can double your money. So with one of each, you can end up with $2, or you should expect to end up with $2 in this case there. Now, what about if we have a little bit of an imbalance? What if we have a 2-1 scenario in this case? And let me move this up a little bit. I want to keep things fit together so we have enough room for everything here. Now this time there's more red. So you have a 2/3 chance of doubling your money. And then I'll write this one out there, right? You got rid of one card, red card, so it's M of 1/1. But now we know that value. So we have 2/3, then you double, and then the previous scenario, right? We said that you doubled your money. You ended up with $2. 2 times 2 times 2 is 8. So we would end up with $8/3 in this scenario. Now, let's start. Well, let me write out one more, and then we'll speed up for the 3s here. Now we have a 1/2 chance of being correct again, 2, and now we go to the unbalanced case there, 1 and 2. Remember, we're always having this symmetry stuff going on. So we have 1/2 times 2 times 8/3. And so we actually have an expected amount of 8/3 in this scenario as well. Now, what about getting to our one we actually want? Well, M of 3/2. Now we have a 3/5 chance of getting this correct. Then you double your money. And then let's speed this up a little bit here, right? Then you're getting rid of one of the red cards. So our 8/3 value is going to come in here. So we have 2 times 8/3 then in this scenario. So in this case, the 3's cancel. 2 times 8 is 16. 16 over 5 in that scenario. Lastly, here, drum roll for M of 3/3. If you're seeing a pattern here a little bit, this might be a little bit anticlimactic. Now we get rid of one of the cards. Remember, it doesn't really matter which one of the cards we get rid of. This 16/5 is our 3/2 or 2/3. Same exact answer there. So we have times 16/5, and we get 16/5 in this scenario. So that's what we have in this case. So answer then would be, with those 3 red and 3 black cards, Alice's expected winnings would be $16/5. So a little bit over $3, $3.2 in that scenario. That's how much we would expect she end up with in that case. Now, here's the interesting question that we'll finish the video on. And we'll start exploring this. I'll leave a little bit of work still for you to do. But now let's turn this into a guarantee. And it's not immediately clear that this can be done or what changes we need to make to this setup. But actually, the only change we need to make is that Alice does not necessarily bet all her money each round, right? For example, if she starts with $1, she could bet $1 or $0 or 1/5 of $1. Any amount of money. She doesn't have to bet any value in particular. Of course, she can't bet more than she has, and she'll either win double that. So if she bets 1/5, She loses that 1/5 no matter what, but she could get 2/5 if she's correct in that scenario. And the goal is to come up with a betting strategy to guarantee that Alice always wins the expected amount you came up with in question 1. So question 1 was about expected values. If we do this regular guessing strategy, all in on whatever there are more of, you sometimes, actually most of the time, win nothing, but other times you win big. On average, you would win, we said, with 3 and 3, $3.2. Can we get rid of all of that chance? So we want to say at the end, you end up with some amount of money without any risk. There's no risk in this case. And it might be surprising, but this is actually possible. Now, even if it's a math question, right? This is a math question. That doesn't mean that you can approach it like you might a scientific thing, right? Let's collect some data, analyze that data, see if it maybe helps us along the way. So let's start with some of our values. M of 1, 0 is 2, right? If there's only one card left, you can double your money. And so we also said, well, if there's 2 cards, you still are expected to double your money. Well, let's look at that a second. What is this implying? What is this kind of saying maybe the right strategy would be? Right? So a way to think about this is, right, for the M11, right, just don't bet. And we'll come back to this in a second, but I want to put it here right away. If all we can do is double our money, I might as well wait and say, hey, just don't show me the first card, or show me the first card. I'm betting $0. And then I know what the second is, because there's one of each, and then I'll double my money. And if we look at this closely, if you saw some of the numbers we had, this pattern actually somewhat stays the same. If we have 2 red and 2 black, we're in no better position. Our expected amount of winnings is no better than M21. M33 is no better than M32, right? We're always going to get this imbalance or advantage after seeing that first card. So this brings us to our strategy or main idea. This suggests that we don't bet unless we have an advantage. 3-3, 50-50 chance on both. Don't bet anything. We're not going to risk anything. Now we have 3-2. Maybe we can take advantage of that and go from there. And this is actually going to be our main idea. It's still a little complicated, but let's look at this strategy and see what happens with 2-2 in this case there. So remember what we're saying here then. So before we see the first card, right, we're going to bet nothing. We bet $0 on the first card. We do not have an advantage. Now, 50-50, it doesn't matter whether the first card is red or black. So let's assume that the first card is red. So that first card is red, and then we can go from there and see what happens in this case. So, right, for the second card, let's explore our bet in this scenario. Now, if the first card is red, right, note what we have is we have 2 black cards and 1 red card there. We're in this 2-1 scenario. The first card was red, so there's 1 red remaining, 2 black remain. Now, here's where things are a little bit confusing, but think about the advantage. In the first scenario, there was no advantage, 1/2, 1/2. No advantage, no bet. In the second scenario, what is our advantage? We had 2 and 1, 2/3 and 1/3. So we're actually going to bet the advantage. We're betting the difference of those probabilities. So we're betting this, so we're betting 1/3 on, of course, we're betting it on black in that scenario there. So here we actually have some probabilities that can happen, but we actually don't need to worry about the probabilities because we're still talking about guarantees. So there's a 2/3 chance we are correct, right? So the second card could be black in this scenario. Now, what happens in that case, right? So we won some money there, right? We bet 1/3, so we won. Our total gain is 1/3. So we have, let me say, whoops, we have 4/3 dollars in that case. So, right, that's kind of what we have in this scenario there. Now, one red, one black. Notice we have one of each left. What was our strategy there? Well, then we just wait and double. So this scenario then, we know this again can be thought of recursively. We know that in that case, we wait for the third card, double on the fourth, so we can end up with 8/3 dollars in that scenario. Notice this is the value that we wanted from before as well. Now, what happens if we have a red card? Now, this is bad because we now lost 1/3 dollars. So here we have then, right, we're in this case where we're down a little bit of money. So we have 2/3 dollars. Now, that's the negatives. What about the positive? The first two cards were red, meaning that for what we have left is 2 black cards. So we know that from here, the other 2 cards have to be black. And this is the magic. We now know that we can double our money twice. And 2/3 times 4 is 8/3 in this scenario. So no matter what, we end up with 8/3 dollars in this case. And it's 100% chance, right? We don't need to label any probabilities here because we aren't actually doing the expected value or anything, right? Yes, it's more likely we go down on the left side of this tree where it's black, but either way, we end up with 8/3 dollars in that case there. Now, let's not spend too much time on this, but let me just introduce how to get started with 3 and 3, right? So the first card here, right? Again, no bet. We can think of that the same way we did before. So again, we can assume it's red. And let's look at some simple examples here then or let's review our strategy, right? For the second card here, now we have 3 black left. There's 3 black and only 2 red left. So we bet the advantage. So we bet here 3/5 minus 2/5 equals 1/5 on black. So we have that scenario there. And then you can go through our tree diagram again. So if it's black, right, we now have, we've won an extra 1/5 dollar. So we have 6/5 there. And it actually is pretty quick, but I'll let you think about this. Notice that that means we're in a smaller scenario. Now we have 2 red, 2 black. Think about what multiplier we would have in that scenario. So what about if it's red here? That is our bad scenario where we're losing money. And now we have, in this case, right, we're going to have 4/5 dollars here. Now, last thing we'll do quick is I want to explain the betting strategy here, right? So here, what is happening? What is our scenario? Well, we have BBB. We still have all 3 black cards, and we only have 1 red card. So again, we're going to bet the advantage. And there's one clarification I want to make here. Our advantage is 3/4 minus 1/4. Our advantage is a half. But remember, we should think of these as fractions. You're betting a half of what you have. So in the other scenarios, we always had all of our money, so this didn't come into play. But in this scenario, you have 4/5 dollars. So you're only going to bet 2/5, half of your money. Your advantage is half, so you bet a half of your money on black in that scenario. Again, you can either win or lose, but I'll leave it to you to look through those cases, and you'll see you actually always end up with 16/5 here. So I'll leave it to you to check. So ... you have to do a little bit of homework here, right? You end with 16/5, which is what we had expected from before. So that no matter what, you have as a guarantee here as well. Okay, that brings us to the end of this video. Thank you all for watching. Stay tuned for a new topic next week. Give us a comment if you have ideas of something happening in the world that you want to hear the math behind. Like the video, subscribe to the channel, of course, and I'll see you all next time. Goodbye.